Think about the last electronic cable you threw away. It almost certainly did not break in the middle. It failed within 2 centimeters of one end, at the exact point where the flexible cord meets the rigid plastic plug. That specific location fails because it forces 2 conflicting physical properties to negotiate space. You have a completely flexible object colliding abruptly with a completely rigid housing. Without a mechanical gradient between the two, a sudden transition concentrates every bending cycle into one single microscopic line of copper strands. That gradient is called strain relief. When engineered correctly, the cable curves away in one easy arc. When it is ignored, you have built a hinge with no pivot, placing maximum stress on a spot the user will flex 1,000 times a year. It's tempting to call this an unsolvable mystery, but material stress limits are exhaustively documented. Labs run routine flex endurance testing for bodies like UL, BSI, and 2. The USB Implementers Forum codifies minimum bend radii for these materials. The engineering isn't obscure. Since nobody is short of data on how cables bend and break, these chronic breakages point to a completely different cause. The physical tearing of the wire is a symptom of a deeply flawed timeline in the design process. Here is the standard pattern for bringing hardware to life. The physical enclosure is designed, the layout is frozen, and the manufacturing tooling is committed. Only after the object is finished does someone look at it and ask where the power cord should go. Because the object is locked, the lead is sourced as an afterthought. That sequence triggers a cascade of inevitable compromises. First, the exit point for the cable becomes whatever random space the internal components left available. Next, the exit angle is dictated by whatever the external wall allows. A lead leaving the bath as a device that sits against a wall is forced through 90 degrees before it has traveled a centimeter. Finally, the transition length is starved. Proper strain relief needs physical room to build an arc, and a shallow housing simply has no space remaining for that geometry. What should be calculated mechanical engineering devolves into a desperate spatial workaround, and the consequences extend past the junction itself. When jackets are specified late in the process, you get coil memory. A cord that sits in a box for a year takes that shape permanently, which is why some cables fight your movements forever. Then there is the issue of handedness. An arbitrary exit position on the side of a device makes it convenient for half the population and permanently awkward for everyone else. The stakes get much higher when you look at repairability. If a lead is permanently captive to the device and the strain relief fails, the entire functioning product becomes scrap metal. None of these are actual cable problems. They are enclosure problems that get charged directly to the cable's lifespan. We have to reconsider what the product actually is. For a vast majority of devices, the cable is the physical handling path of the interface. It is the component the user touches the most. Institutions like the Design Council treat this entire use experience as the true design scope. Longevity lives in obsessing over the unglamorous parts. The solution to the chronology problem is entirely straightforward, though almost never executed. You draw the cable at the exact same moment you draw the enclosure. Treating the lead as a separate, sourced afterthought guarantees failure. You have designed a beautiful object with a countdown timer attached to one corner. If you decide the exit point, the exit angle, and the transition length while the internal layout is still soft, the cable becomes a single continuous object with the body. The internal architecture can physically move, gracefully accommodating the rigid laws of bending physics rather than fighting them. This concurrent spatial awareness separates adequate drafting from true design intelligence. It requires treating the junction as the center of the user experience. Design decisions are practically free during the sketch phase. They are brutally expensive once the tooling is locked. You have to see every angle and understand every constraint before you build.